Okay, welcome back. Okay, this is the last topic for the CLO number 2. Another example of a full-scale PDM diagram. Okay, the one that we mentioned previously was just a concept, and we expect students to basically able to draw the PDM diagram based on the given list of tasks. So you must basically have the ability to construct properly and then do the forward pass, backward pass calculation, eventually identifying the project completion duration, critical path, total float, and free float. And from that, we can ask a few more questions with regard to the impact of if such activity being delayed. So basically, if you already have the total float and free float values, you can easily answer the question. Okay. All right. Now let's go into this. Okay. We already mentioned about the concept. I do not want to go into this one anymore. Okay. Let's go straight away into the example. Let's say we are giving, you are given a few activity or tasks, start until finish. Okay. So how many activity? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So meaning to say 11 plus start and finish 13 boxes must be on the paper that you draw. Okay. 13 boxes must be there. You can put the boxes there first, but then just matter of connecting them. Duration of the activity are given, predecessor are given, and you notice why we call this thing as a PDM diagram? Because here, you notice here, we do have other than finish to start relationship. If, for instance, we do not indicate, for instance, B, we just simply put B. Automatically, B is basically B and A, B and E do have finished to start relationship. This is by default. So we don't have to indicate FS, no. We only indicate if anything other than FS. For instance here, other than FS, FS minus 1. So this is also FS, but then it basically do have lag of negative 1. Then what else? Here, example, finish to finish minus 2. And then this one is finish to finish plus 3. Then this one finish to start, but plus 2. The rest basically do have relationship of finish to start, which we do not spell out here. Automatically, it is understood. Relationship mean finish to start. If it is other than that, lag and lead, then we are going to indicate something like this. So when you read the diagram, you must basically understand, oh, this is what the relationship supposed to be. Okay, now we are going to construct. You know that activity, the milestone start, and start. There are 3 activities connected from the start. So you know already A, B, and D are the starting activity, by the way, but it is connected from the start. So you can draw the diagram. Okay, we are going to draw the diagram bit by bit. Start A, B, C, D. Okay, so we draw the diagram. Start. All right. And then A. We draw it somewhere here. A. And then B. B down here. That's why normally, if for instance, other people might basically draw B here. B. And then D, for instance. Never mind. because you do not know the whole connection yet. Later on, when you see the whole connection, then you can basically revise so that the drawing looks good. But if, for instance, during final exam or test, you might not have the luxury of time, whatever thing that you draw, if the connection is right, then be it, okay? You don't have to basically erase and then redraw until you waste a lot of time. No need to do that. Okay. Let's say this is the things that you draw. A, and then D is there, and then C, you know that it is connected from A. So A is already here. Then you draw just one C, but then you need to notice about the relationship. So remember, the left side of the box indicates start, and the left side of the C indicates start. So this is how we label the relationship start to start plus A. Okay, now we already completed the first 5 activities or tasks. So continue with the rest of the activity bit by bit. Okay, E. E is connected from B. So find B. Okay, B is here. Then just draw one box of E and then connected from B. So E finish. Then go for F. F is connected from A. So F, A is already here, then connected, but then label it properly because it do have a negative lag. Finish to start with negative lag. And then G, G is connected from A and D. Okay, since A and D already in the drawing, just draw one box and then connected the arrow from A and D using finish to start relationship, okay, by default. And then H, H is connected from C. So C is here already, then just draw one H and then connect with the arrow, okay? So now we already completed majority of the activities. The rest, I, here. I is connected from F and H. So we already have H, and then we already have around here. So just draw one box, but then use a proper arrow diagram, arrow relationship in order to indicate from the previous activity, F and H. You notice that this is a very special relationship that we never used before. Finish to finish -2. Okay. And then G. J is connected from 2 activity and very special activity, special relationship as well. So J connected from E, finish to start +2, but G using this relationship. Okay. Then K. K connected from E, straightforward here. And lastly, the finishing milestone connected from I, J, and K. Okay, I, J, and K. All right. So you notice that when we add start and finish milestone box there, so everything is interconnected. This is a good kind of network diagram. Now, after completed the diagram, you can basically double check by going back the listing. Finish. Finish is connected from IJK. Okay, finish. Connected IJK. Okay, correct. Then you go into K. K connected from E. All right, so this is correct. That is how you double check your drawing. Okay, double check. So once you get the drawing right, the only thing that you need to do is basically to do the forward pass and backward pass. Okay, now we are going to do the forward pass. Remember what is forward pass? Forward pass is the calculation from the left to the right in order to get the value of early finish. This is the formula. So we are going to start with 0 here. And start basically do have 0 duration, 0 plus 0 equivalent to 0. So this 0 will go into here. See? A, D, and B. So that's why I mentioned to you, A, D, and B are actually the starting activities. Without the start milestone, we already know that activity basically start from A, D, and B at the same time on day number 1, okay? Day 0. Okay, now we need to solve each box, okay? Each box using this formula. Solve the calculation within the box. So for A, 0 plus 7 equivalent to 7. For D, 0 plus 10 equivalent to 10. Now we already completed D. B, 0 plus 5 equivalent to 5. So A, D, B already completed the values. Now we can go into C. Okay, C relationship is start to start. Start to start, so you notice that it basically must take the value of the starting of A. So 0 will go into this line, but then we need to add 3. Okay, we need to add with 3, 0 plus 3 equivalent to 3. This is what the lag value will influence the calculation. Okay, so A and C, they basically do not exactly start at the same time. C will start a little bit late by 3 days. Okay, so that is what the lag is all about. So when we already know C start at day number 3, day 3 plus 11 equivalent to 14. Okay, then for H, transfer here, 14 plus H plus 8 equivalent to 22. So now we already completed until H. Okay, let's go into F. How do we calculate the ES for F? Okay, F is coming from A. So A is basically this value, 7, will be transferred here, but then there is -1. So remember the formula always for the forward pass, plus 7 plus -1. As if 7 minus 1, then equivalent to 6. Because negative mean overlap. So the starting of F is ahead of time by 1 day. And that's why 6 is there. Okay, then within the box, 6 plus 5 equivalent to 11. And then we resolve this G first. Okay, G do have 2 activities coming from A and D. From A and D. So we choose which one is the bigger value. Of course, 10 is the bigger value. 10 will be here. 10 plus 8 equivalent to 18. Okay, finish on G. We resolve E. E very straightforward. Okay, 5 here. 5 plus 9 equivalent to 14. Okay, we can resolve activity K as well because K is connected from E only. So this 14, 14 plus 3 equivalent to 17. Okay, the only remaining activity is I and J. I and J. Okay, now we need to focus on I. Okay, I, there are 2 arrows coming in from F and from H. So we need to do 2 calculations and then we see which value is the bigger, and the bigger value will basically remain in the box. So how to do that? Let's say I from F. If I from F, here, this is the value that will be in this box. If it is 11, then we do the calculation. 11 plus 4 equivalent to 15, but we do not put inside the box yet. So we do have one alternative value. As if it is I is coming from F, so this is the value, 11 and 15. But I is also, there is one arrow coming from H. But now, using the FF relationship. FF relationship meaning to say, the value from the back of the box is the one that we need to consider. We do not take the value of at the back of the H, for instance, and put here. No, no, no. We must follow the arrow. So 22 will follow the arrow and it will be in this, the back of the box. But since it is -2, so how the calculation looks like? 22 plus minus 2. Because remember, this is a forward pass. Everything need to be plus with plus. 22 plus minus 2 as if 22 minus 2 equivalent to 20. So this 20 is the one we put it here. This is how we determine the values. If it is 20, then what is the starting of the starting duration? So we work backward. 22 minus with 4. So we must basically start with 16. 16 plus 4 equivalent to 20. That is the matching, okay? The matching value. And you notice that this is one alternative. Whereas the top one, 11 and 15, is another alternative. Which one is the bigger value? And of course, this one. So that's how 16 and 20 will be locked inside this activity I. And this line here is the dominant line, not from the F. F is not the dominant line because it gives a smaller value. That's how we evaluate in terms of what we call relationship, arrow relationship that goes into one particular activities. Okay, we do have a similar concept for J, but the results are different. Okay, now for J do have two arrow coming in. One is from E here, and one is from G. So we can evaluate if if arrow is coming from E, how would the value be like? So we take 14, then we need to add with 2 here. 14 plus 2 equivalent to 16. If it is 16 is here, then we add with the duration, 16 plus 12 equivalent to 28. That will be one alternative value. This is one set of value. But what if J is coming from G? How the values look like? Okay, now, since it is finished to finish, the value is, this 18 is the one that we are going to log in. But 18 will go into here, 18 plus 3 equivalent to 21. So 21, if it is 21, then we minus with 12. Okay, we minus with 12. 21 is still smaller than 28. Anyway, okay, we don't have to minus in order to get the value. We know already between 21 and 28, the bigger value is 28. So 28 and the 16 will be the value that we log. And now the dominant relationship is coming from E. This is the dominant relationship, not from G. It's unlike the between I and H. So that is how we evaluate the values that sit into the subsequent box based on the type of relationship, whether it is coming from the front or at the back. Plus, we need to consider the lag and the lead. Okay, now we already completed the box I and J, and we notice that this value 28 is the maximum number inside this box, and we know that the project is going to end in 28 days. This is the project completion days, and we can log this value and put it here in order to complete the finish milestone. 28 plus 0 is equivalent to 28. So we know that the project completion date is 28 days. That will be the forward pass. Okay. After we complete the forward pass, then we can do the backward pass. Okay, backward pass. We copy 28 into this late finish. Then within the box for finish, 28 minus 0 equivalent to 28. And this 28, we are going to transfer here using the same back arrow, 28, 28, and 28. So that is how we transfer the value based on whatever the previous relationship, because it is finished to start. Okay, now let's focus on I and H first before we go into the rest of the calculation. Okay, once we log this value, okay, within I, it is easy. We just simply minus 28 minus 4 is equivalent to 34. Okay, fine. But if you notice between I and F do have relationship of finish to start. And how do we transfer the value from I into F? It is easy because we are going to use the same arrow here. This 24 will go inside here. Okay, now we already have the values. But the issue is that, how do we transfer the value from I into H? The value from I into H. We cannot basically use 24 and put inside here. Cannot, because it is not finished to start. Remember, I told you, we must basically use whatever the arrow it basically come from. Since it is coming from the back, so it is the back value here. 28 is, this is the one that we need to consider. Okay, I highlight here 28. And this 28 will go back according to this line. And since it is minus 2, what happens is that 28 minus 2. This is backward pass. We need to do this. 28 minus 2 become 30. This 30 is the value that supposed to be here. Okay, that is how the value 30 come from. Why? Because the type of relationship is finish to finish, and then we also have this negative 2. Okay, so the issue is that once we already have the value inside one particular box and we want to go back into whatever these the previous activity, that is how to do that. Okay, but now the issue with I and H, it basically do not have the relationship, the typical relationship finish to start. It basically have finish to finish. And how do we do that? We need to consider which value that relate in terms of that relationship. In this particular situation is the back value, not the front value, not 24, but it is 28. Then we go back. Then there is another issue with regard to the negative lag. So we need to take into account as well. Then we are going to end up with 30. Okay, now let's say if, for instance, you already have this 30 within the box, you are going to minus as normal. 30 minus 8, you are going to get 22, and you do the rest of the calculation. Well, you thought that your calculation is correct. You notice something weird about this issue. You notice the value of 30. When do we finish the project? We are going to finish the project on day 28 only. That is the project completion based on our forward pass. And how come we have 30 days there? Which means we are going to have the late finish of H, which is later than the overall project completion date. If you are not being careful, from the calculation concept, it is right. That is the way to do it. But you miss one thing. You miss one thing in terms of, remember we told you, when we do the backward pass, when we do the forward pass, we are going to take the value, which one is bigger value, in order to put into the box there. But when we do the backward pass, we are going to take whichever the lower value and put into this box. And now the 30 that we get here is one of the alternatives. We need to ask the question, is it 30 that we are going to take or 28? This 28 is the project completion date, and the project cannot go beyond 28. Cannot go beyond 28. So 28 is the one that we are going to consider. And 28 should be here instead of 30. That is a proper, a logical consideration. If, for instance, you do not consider this thing and you just simply log 30 in this box, yeah, you can do the rest of the calculation, but actually the whole calculation is basically wrong. Is incorrect. Okay, so that's why I put it into the next slide. Okay, the new calculation, and you see, you notice we log 28 is here. Why 28 or 30? 30 is based on the real calculation, which is correct calculation, but then consideration have to be logic based on the overall project completion period. And we already checked with the software, Primavera, Microsoft, long time ago, and it basically give the same answer. And I think in one of the previous final exam, we do have the same question that we asked students, and some of the students basically did not get the right answer because we already showed them in the class, this is the situation, they still make the same mistake because anything cannot go beyond the project completion date. There is a consideration, or which one is lower? Okay, now, so this is the right calculation. The previous one is the wrong calculation. I just want to show you how do we get the figure 30. Okay, similarly, when we do the calculation here, 28, we are going to put it here. 28 minus 0 equivalent to 28. We log it. 28 here, 28 here, and 28 here. And then 28 here, we are going to transfer, and then again, 28, 28 minus 2, of course, it becomes 30. So 30 is just one of the consideration, okay? Or 28, why? Because the project completion is 28. So 28 is the one that we log. We log, and this is the right figure that we put into H. And once we already log, and the rest basically just follow similar concept of calculation. 28 minus 8 equivalent to 20. Okay. Now let's go into another situation, J and G, because it looks the same, but then why the answer different? Okay. Now between J and G, this figure, 25. Where do we get 25? This one. 28, we use the forward FF relationship, but then we need to minus with 3. 28 minus plus 3, we need to say 28 minus 3, equivalent to 25. Why? Basically, we do not adjust to any other figure. 25 is within the project, so it is acceptable. The only issue is regard to the end, what we call the end activity or task that we need to be very careful, because we need to log at whatever the last day of the project. Okay. Okay. Now, that will be the issue. The rest basically using the same concept of calculation. Let's calculate C. So once we have 20 here, and then C basically transfer here 20. 20 minus 11 equivalent to 9. Okay, so we complete I, H, and C. How about F? F straightforward. From I here 24. 24 transfer here. 24 minus 5 equivalent to 19. All right, so we finish on F, I, H, C, and H already. Now let's go into J. J, 28 is here from the previous transfer. 28 minus 12 equivalent to 16. Okay, and then how do we get into G? 25 is here is based on FF relationship. Once we log 25, then the rest basically we do within the box. 25 minus 8 equivalent to 17. Okay, now J and G already completed. How about K? K is straightforward. 28 minus 3 equivalent to 25. Okay, 25 here. And then E. Okay, this is, you need to be very careful with E, because E, there are two arrows coming back. One is coming from K, 25. 25, if you transfer here, it looks like a bigger value, big value. But how about if E is coming from J? So the value that we need to take into account is 16. 16 going back, but we need to minus with 2. Remember, backward pass is basically minus. 16 minus plus 2. 16 minus 2 equivalent to 14. So 14 is this value that we get from J, and it is lower than 25. So that's why 14 is being chosen. So one, we log the value 14. 14 minus 9 equivalent to 5. And then for B, we straight away transfer 5 here. 5 minus 5 equivalent to 0. Okay, now B, E, and K already completed. We can do D. D, very straightforward, because D activity is coming from G, 17. 17, transfer here, 17 minus 10 equivalent to 7. Okay, now we already completed D. The only incomplete box is basically A. And when you notice A here, this is A. Notice A. How many arrows coming back into A? There are 3 arrows. If you are not careful, you might make a mistake. You might basically say A, there is one activity coming from F, one arrow coming from F, and another arrow coming from G. Yeah, but you must remember there is one arrow coming from C, but from in front instead of from the back. So meaning to say, how do we get this value? From, we need to evaluate 3 lines. One coming from C, one coming from F, and one coming from G. Okay, step by step. Then only we are going to choose which is the lower value. Okay, now let's focus on this one, A. This one, A. Actually, this value, if for instance it is coming back from F, so 19 is the one that will be chosen here. 19. I just put it here, 19. But 19 is quite a big number. How about if it is coming from G? 17. 17. So between 19 and 17, 17 is much lower. But how about if it is coming from C? But the issue with it coming from C is not from the back, from the front. So meaning to say, this value 9 will transfer into this box, and then, but need to be deducted with 3. How do we do that? 9 minus plus 3. Remember why I put plus 3? Because lag can be positive or negative. There could be situation where you are going to deal with -3. So 9 minus 3, then 9 plus 3. So you need to be very careful. But in our situation is +3. So 9 minus 3 equivalent to 6. Okay, so if this is 6, 6 will be here, then how do we get the value at this box? So we add back with 7 and see how. 6 plus 7 equivalent to 13. So you see, between 13, 17, and 17 and 19, which one is the lowest value? And of course, it is 13. And where do we get 13 from? From here, from the C. Okay, start to start plus 3. So that's why you need to evaluate each of the relationship and then note down the values. And if it is backward pass, we are going to choose the smaller value, which is the dominant is coming from this line. So now we get 6 and 13. That's how the value come from, actually coming from C. Okay, now all the box already fill up, and you notice that we start with 0. We start with 0. And then how do we get this value from? This value we are going to get from the either A, D, and B. You notice in B we do have 0. And 0 will be transferred here. 0 minus 0, and we are going to come back with 0. That is a check. When you do the calculation, you have to make sure to come back with that value. If you make mistake somewhere, that's why you are not going to get the right value. Let's say you deduct with the wrong thing, or you copy the value from the previous box wrongly, you're not going to get the values right. Okay, now after you complete those things, okay, after you complete those things, you notice next step, you can calculate total float. It is very easy to calculate total float because total float is just the differences between this value and this value, or this value and this value. For instance, H, 28 minus 2, you are going to get 6. This is what total float is all about in blue color. Okay, total float in blue color. I already calculated for you. Okay, so you cannot get wrong. If you use this value, the front value, 20 minus 14, of course you are going to get 6. So you can calculate total float very fast, because in the assignment, in the upcoming test, and in the final exam, we always ask students to complete total float and free float value for all activities. This is when some students might be in trouble, the one that not coming to the class. I notice there are many people not coming to the class. Well, never mind. We are going to get those person at the end of the semester later on. Okay, now we already completed total float value. Now, the last one, we are going to calculate free float. Okay, free float, if we use the formula that I mentioned to you before, let's say between F and I, 16 minus 11. 16 minus 11. 16 minus 11, you get 5. Okay, that is very easy to calculate total float. Straight away, you can do that. Okay, let's take between B and F. Again, 5 minus 5. Of course, you get 0. Okay, you can do that. But the issue is that how do we calculate free float using the simple formula that I gave you if the situation between H and I, this is the issue, okay? Between H and I, Okay, I go back to the concept first. This is generic formula, free float. By right, early the differences, early start and early finish of in between activity. If you use this formula, meaning to say you are going to take this value minus with this value. 16 minus 22, what are you going to get? You cannot use this formula. In the case of different type of relationship, if it is finished to start, then of course, this formula work fantastically. But not all the relationship do have that kind of finish to start relationship. In this case, H and I. But then how do we calculate free float? Again, we can still calculate free float using the concept of where basically the value come from the relationship. Okay, we can compare like this. This value, we need to compare with this value. That is the right comparison because the definition of free float is basically what is the free time such activity have um, uh, without affecting the starting of the subsequent activity. The starting basically refer to this concept. The starting basically refer to this concept originally. But then if the relationship is finish to finish, then how are we going to use that kind of situation? Well, never mind. Don't worry about that. We can still use using whatever relationship. Okay, now 20. Okay, if we use the same concept 20, but then you need to basically go back to the relationship, go back to the arrow 20 minus 2, which is equivalent to 22. Now you have the 22, you need to minus with the 22. 22 minus 22, you are going to get free float of 0. And in fact, if you do not want to use this kind of calculation, it sounds like complicated. Well, don't bother about that. You know, when we mention in the fourth pass, where do we get this value from? We get from this line. We get from this line. So meaning to say, in between this and this, there is no such thing as a free time because whatever the value that we put it here is coming from here. That is the logic. From that logic, you know already. There must not be any free time in between. Very similar to this concept. There is no free time in between because the line is coming from that direct line. If you understand the concept of the free time in between activities. But if we are talking about between F and I, yes, there is a free time because I will only start on 16 days, whereas F already completed on day number 11. So meaning to say, F do have some free time left in between F and then I. Okay, so what else? Okay, now let's take another example of G and J. Is it the same concept? It is the same concept. Okay, how do you calculate free float? You cannot compare free float directly like 16 and 18. Cannot do that because the relationship is finish to finish. You must compare the value from the back of J here, 28, okay? 28, then you minus with 3, you get 25. 25, you minus with 18, then you get 7. That is the correct way to calculate the free float value. Even though this formula is basically good for finish to start relationship, the rest of the type of relationship, you can use the same concept, okay? Except that you have to look at where basically the value come from. Is it from the back or in front? Okay, you just compare between those two values, okay? All right. Now, E and J, free float. Of course, we know already. But if we want to calculate, you notice there is this value, 16 and 14. If we deduct 16 and 14, then we get 2. Why basically the free float is 0? Well, we miss this thing. We need to take into the account the lag or lead. So the proper way to calculate is basically 16 minus with 2 first, then we get 14. 14 then minus with 14. Then we are going to get 0. So basically what we are doing, we are comparing the starting of the such subsequent activity and the finishing of the current activity that we are trying to get the value from. That is the thing. So whatever it is, total float is very straightforward. You just compare the value of between this value and this value. But when it comes to the free float, I would advise you, even though we can use this generic formula, but when we are dealing with the PDM diagram, we need to take into account the type of relationship and then lag and lead as well. Then only we get the right values. Okay, we get the right values. And free float will not appear in everywhere. If you notice in this diagram, most of the activity basically do have free float value of 0, only selected one. And you know already, when many activities goes into subsequent activities, one of them could have the free float values. You know already where to zoom in. Okay, where to zoom in. All right. So this is just a concept understanding of the whole things that we already mentioned about relationship. Okay, let's say we do have a few statements. We do have activity X and Y. Okay. Statement number 1, start with positive lag. Let's say here, start with positive lag. Here, if we draw the line, maybe you can understand it better. So start, it could not be negative, it will be positive because we delay the starting of subsequent. So positive would be the correct answer for this. Okay, start. Finish with positive lag. We can draw on the other way around. Okay, finish with positive lag. Yeah, FF plus something. Okay, if it is negative, then the finishing would be drawn a little bit on the left side instead on the right side. So this is correct. Finish to start with positive lag. Finish to start here. If we draw something like this, okay, this is finish to start with positive lag. Cannot be, because the starting of activity Y, we basically draw to the left, meaning to say ahead of the finish of activity X. So it cannot be. Okay, this is supposed to be negative instead of positive. So meaning to say statement number 3 is basically not right. And statement number 4, start with negative lag, cannot be because the first one is already the correct answer. And finish to start with negative lag is that is the things. Okay, this is just to give you the understanding of the theoretical concept of lead and lag. Okay, once you understand the lead and lag, later on you will understand how this will be translated into the values in the diagram as what we have done before. Okay, another example. Very simple theory, but some people might not get the concept right. Okay, uh, we are giving the value of early start here, and then we want to know what is the early start value of L, for instance. early start value of L. Okay, some people might basically answer, okay, from K, 9 plus 8 will be 17. So 17 will be transferred here. So the early start of L will be 17. But he or she might forgot about, or L do have connection from J. J basically, the early finish of J, 10 plus 15 will be 25. So 25 is one of the value here. If it is 25 minus with 7, then it becomes 18. Between 18 and 17, which one is the bigger value? So 18 is the bigger value. So 18 is the early start for L. If people who answer basically 17, the answer is wrong. Okay, long time ago, our final exam basically based on objective, and people say, oh, objective question is very easy. You just basically choose one of them without even doing anything. And if you choose 17, wrong answer is there also. We already thought about everything. Okay, so the right answer is 18. Okay, then for instance, another question. We want to know the free float. Free float for L. What is the free float for L? And again, you notice that L is connected into M and then N. The early start of N is given 30. Okay, early start of N is given 30. If we use the same formula before, we just simply compare between this is the early start and then this is the early finish of the L. 30 minus 25. We are going to get 5. 5 is also in the selection. Okay, on the selection. But is it the correct answer? So that's why you need to understand the concept. Okay, so M is not being specified, the starting of M, but of course M will take whatever the value of the early finish of L as a starting point immediately. So M will start on day number 25. And if, for instance, between L and M, that use the same finishing of L, you notice that this value, 25 minus 25, equivalent to 0, the free float of 0. And between 5 and 0, we are going to choose the smaller value. In this case, is 0. If, for instance, the value is not 0, the value is 1, and 1 will be the free float for L, because L only, whatever it is, each activity only have one specific values. If in this case, there are two values, isn't it? So we are going to log the answer from here, because logically, immediately after L completed, M will basically have to start. So there is no free time for L. Even though looks like from L into M, N, like 5 days, but in reality, L only have one life, for instance. So it cannot basically be extended anymore, because one, it is being extended, automatically M will be affected as well. So that is what the concept of free float is all about. Is basically the available free time. That is not available free time. L basically do not have the free time. So in this case, basically, the right answer is 0. If you do not understand the concept, then basically you will make mistake. So this is another typical final exam question, but nowadays we do not give the diagram anymore. The diagram is the one that you need to be constructed from the list of activities. But you notice there are some complexity in the diagram in such a way. You notice activity H. There are 3 arrows coming in, but there is also arrow coming from the back. So you need to be very careful. Okay, you need to be very careful because there could be a bigger value coming from the back or whatever thing. You need to evaluate. So you need to be very careful. This one is also the situation. There are two arrow coming in and out. Okay. So if, for instance, you have the ideas, you do from one activity into another carefully, you should be able to get this value, and you should be able to get the total float and the free float. This one is also the previous final exam question. Okay, you can basically try and get what is this value. This is what we call project completion. If you can fill up the forward pass and backward pass with all the values, and then later on you can calculate the total float and eventually the free float. Okay. All right. So that will be